Hey, what's up, guys? Chung here again. So this time let's take a look at this problem here. LeetCode 536. Construct binary tree from string, right? So you're given like a string with like integers, a negative sign, and and the uh, the left and the right parentheses. And the left and the right parentheses represents the subtree of this of the current node here. Basically, if you have four here, so the first substring parenthesis is the left subtree 2, 3, and 1, and the right one, the second pair of the parentheses is the right subtree. So it asks you to return the basically the tree node. So with this kind of problem, it's kind of obvious we need to use recursions. Basically, every time when we see a 4 here, right? We see a 4 here, we try to find the left, what's the strings for the left subtree and what's the string for the right subtree, right? And for example, here we have a 4 here, so we find okay, so once we find the first left find the first uh, left parenthesis, right? And everything before that, basically we'll have a helper function here, and here we're gonna have the current substring here. So first we with the current substring here, we first find the left parenthesis here. So if there is a left parenthesis, then we know, okay, so there is a left and the right subtree. If there's no left parenthesis at all, we simply know, okay, so there's no left or right subtree for the current string. We can simply return the root node with the current value, right? So if there is a left sub parenthesis, so what do? We uh we start from, okay, so first anything before this left parenthesis will be the numbers here. Let's say the 4, 3, 2, right? This is going to be the index, going to be our starting index. And then we just loop through everything, uh, we loop everything after this index here. And we'll try to find out the matching right parentheses for this one. How, right? Basically, starting from here, we increase every time when we see a left parenthesis, we increase by 1. And every time we see a right parenthesis, we decrease the counter by 1. When we see when the counter becomes to 0, then we know we found this like the matching uh, right parenthesis, right? And then we just pass the substring between those two matching parentheses into a recursion function, right? And we use that one to set the left subtree of the current root, right? And then everything after this one here will be the right subtree if there is anything, right? It's going to be the left and the right. So for the right subtree, we don't need to care about the matching index here, the matching parentheses, because we know the last one of the string it's gonna be guaranteed to be the right parentheses. So basically, we just start from here to here, right? We don't care how many whatever inside in between. We just need to know we just want to pass whatever between those two between the current between the here and the last, basically the last index of this current string, and we just use that as the right subtree. Okay, so with that being said, let's try to code this problem here. So first, mm, helper, right? I'm gonna define a cart string here. All right. So first, if not, current string, right? If there's nothing here, we return a non-value, right? And then, like I said, left tree start, uh, right? And left tree start equals to the current s dot find. We're trying to find the first left parenthesis, right? So here we can do a simple check, right? So if the left, if it's not does not exist, which means if this one is equal to -1, right? Then we know, okay, so this current string doesn't have any subtrees, right? We can just simply return tree node int, right? Int current string, right? We can simply return that. Else, we need to find like uh, left parenthesis counter count equals to 0. Okay. Then we do a while loop, right? While uh, mm, we can set a counter here. Yeah, let's do a counter here for I in range, right? So basically we start from this left parenthesis, right? And then the n will be the length of the n here. So I'm gonna create the n for the current s, right? So basically we're trying to find the ending point of the left subtree, right? So if c equals to the current s I, right? If c equals to the left parenthesis, we do a left parenthesis count +1, right? Else if c equals to the right parenthesis, right? We do a left parenthesis count -1, right? And then we check if left is equal to 0, right? And then we know we find a matching point, right? The matching uh, closing parenthesis. So start, I'm going to do an end here, okay? I'm gonna define an end here with 0, okay? Right. So, and then we know the left is the current I, right? And then we simply break the current loop because we know we already finished, we found it, so we don't have to continue. Then uh, the root, right? Then the root equals to tree node. No, we can create the root at the beginning here. So here, basically same thing here, right? Int. Since we find the left parentheses, so we're gonna use everything start from until that index that start to be the value of our root. Basically, the current s to the start, right? So basically everything before this left parenthesis will be our value for the current root, right? And then let's assign this root dot left, right, equals to the helper, right? We're going to do a helper here, and we're going to do a substring basically, right, of the current s from where? From, we're going to remove the starting and ending parentheses, right? So that we have the pure string for the substring for the left subtree. That's going to be since notice here, since this the index of the left subtree start is the parentheses, and we want to move this one forward by 1, right? And the end point will be the left subtree end. This is fine because the start is inclusive and end is exclusive, right? So we can use this. And how about the right? Like I said, the right is just the end point, right? So remember, the end point is this, like, for example, is this like a closing parenthesis, and we want to move forward by 2 so that we can add this 6 here, right? Because we want to skip this the current ending. Let me write this down here. Maybe the font is too small. So 2, 3, 1, 1, 6, 5, right? So, for example, if assuming we write here, right, and then in order to find the right the string for the right subtree, we need to move this like current uh, ending point forward by 2 so that it can skip the current closing parenthesis and the next open parenthesis, right? So that's why we need to point it this one to here. That's why the starting point of this right subtree is going to be the end plus 2, right? And how about the end? The end is going to be n minus 1, right? Like I said, we're going to skip the last parenthesis here, right? The closing parenthesis. That's why we do n minus 1 here. In the end, we simply return the helper, right, of s. Oh, sorry, forget. So here we're going to return the root, right? So this it should just work. And let's see, current current C, sorry, current S. Oh, sorry, what am I doing here? Need a substring here, and okay, so all right, so this one accepted. Let's try to submit it. All right, cool. So it passed. All right, let's do a quick recap here. So basically, uh, we do a recursive call. For each string, we try to find the starting point of the left subtree and the end point of the left subtree, and then we pass whatever string it contains in between to a recursive call. Same thing for the right subtree. In the end, we just return the root, right? All right, cool guys. I think that's it for this problem. Thank you so much for watching the video, and I hope you guys like it. And yeah, I'll be seeing you guys soon. Bye bye.